Good morning to everyone. In this video, I am going to discuss about Dijkstra algorithm for shortest path. So most probably nowadays it is applicable in Google Map because if we want to travel from one place to another place, that is if another place is new for us, then we will use Google app to show the shortest route to reach the destination. So this is the main application of this Dijkstra algorithm is nowadays Google Map. So here we are going to identify the shortest route to reach the destination. That is the main concept behind this. So here, for example, if I have two vertex, one vertex is source, another vertex is destination. In between, if I have one more vertex, so source vertex, intermediate vertex, destination vertex. In those occasion, intermediate vertex is directly connected with source vertex. So the distance between the source vertex as well as the intermediate vertex will be written on the intermediate vertex. Whereas the destination vertex not directly connected with the source vertex. So initially I will mark the destination vertex as infinity. Then by using these two formula, I will calculate the distance between source as well as the destination vertex. Assume that intermediate vertex as u and destination vertex as v. C of u comma v is the weight, the edge which carry the weight between u comma v. So d of u means distance between the source to u vertex, that is intermediate vertex. Now if d of u plus cost of u comma v is less than d of v, that is the destination vertex, then destination vertex distance from the source will be computed as follows. D of v is equal to d of u plus c of u comma v. That is the formula. If we keep on apply this formula, then we can easily find out the shortest route between source and destination. Now consider this example 1, 2, 3, 4. There are 4 vertex. Each vertex is directly connected with all other vertex. So the time complexity for this Dijkstra algorithm will be, when I consider shortest route between source and destination, I must need to consider about all its connected vertex. So if there are n vertex, then I must need to consider about all the n vertex together to compute the shortest path. So n by n cross n will be the time complexity, because for each and every vertex I have to consider about each and other vertex. So if n vertex are there, then I need to consider n times about all the vertex. So n cross n means n square. Time complexity will be measured in terms of big theta. So big theta of n squared will be the time complexity for this type of algorithm. This is an author Dijkstra who invented this Dijkstra algorithm to identify the shortest path. And one important thing I want to say, the Dijkstra algorithm will work only for non-negative weight. A edge should not have a negative value. The edge always must have a positive value. Then only I can apply this Dijkstra. Otherwise, it won't work out. So here the solution will be single source shortest path. Means that there will be only one source and may have many destination. Source cannot be more than one. It must be only one. I am going to approach greedy method to identify the shortest route. The output will be the length of the shortest path between source to destination. Here assume that each and every vertex will be considered as a city. So now I am going to travel from one city to another city with the help of Google Map, because nowadays it shows the shortest route. This is what this part reveals. And as we have discussed about the time complexity, n by n, that is order of n square. Now consider this example. there are 5 vertices A, B, C, D, E. Initially, I don't know about the distance between source to all other vertices. So, here I am going to consider only one vertex, that is my source. So, A will be considered as a source. The distance between A and A will be 0 because same vertex. So, I will mark it as 0. But I don't know about the distance between source vertex with all other vertex. So the remaining all other vertex distance will be remarked as infinity, represented as infinity. Distance from A to B infinity, distance from A to C infinity, A to D infinity, A to E infinity. But A to B carry weight as 10, A to C carry weight as 3. In those situations, I must consider the shortest route from source to all other vertices, that is 3. So now I'll start from A, then I'll move towards C instead of B because B is 10. I don't want to choose the largest value, I need to choose the small value. So I'll choose from A to C path. Next, after I reach C, I had traveled from A to C 3 kilometer. Assume that kilometer, 3 kilometers. So instead of infinity, I'll put 3. Next, I'll consider now A as well as C value. Next, what I'm going to do, now A, then AC. Next, what I'm going to do, I'm going to consider from C to all other vertices. From C to B, distance is 4. From C to D, distance is 8. From C to E, distance is 5. C carry value 3. From C to B, if I am travel, C value 3. C to B travel value is 4 km. So 3 plus 4, 7. C value 3. Distance between C and E is 2. So when I reach E, it will become 5. C value 3, distance between C and D is 8. So if I choose the path from C to D, 3 plus 8 value will be 9. So for those occasion, next I need to make a change. How now? What are the things have been considered? A, C, B, D, E will be considered. My objective is I must visit all the vertex. A, C, E will be considered because in this presentation, in this point of view, only C to E is the shortest route. C to B, C to D, C to E. When I compared with all other values, C to E is the shortest route. So I'll choose C to E only. So now it becomes C to E. It becomes 5. Next, what I am going to do, from E to D I need to compute. E value 5, E to D will take 9 km. So 5 plus 9, it will take 14 km. But already I have chosen C vertex which has value 3. From C to D, 3 plus 8, 11. And one more thing, from C to B, 4. 3 plus 4, 7. From B to D, 7 plus 2, it will become 9. So 11 at last it will become 9. I'll explain. Now it becomes 9. So in this case, I considered about A, C, E, B. Next, after reach D, I will also include D vertex in this case. So this is all about Dijkstra algorithm to find out the shortest route between source as well as destination. So already I have given you the real life applications, that is Google Map, and also the time complexity will be order of theta of n square. So this is the, as I said before, traffic information system or most prominent use. Mapping, that is MapQuest and Google Maps are the examples, and routing systems are the best applications for this Dijkstra algorithm. Thank you.